Hello everyone, I'm Duyên. Our graph is graph 7. Our presentation talk about virtual methods and polymorphism in Sysad. In our group, there are 4 members: Đặng Thị Kim Ngân, Huỳnh Thị Mỹ Duyên, Phạm Nguyễn Hoàng Duy, and Nguyễn Phúc Hoàng Duy. In our presentation includes 5 contents. The first one, virtual methods and dynamic binding. 2, abstract class. 3, polymorphism. 5, method of writing. And the last one, interface. The first one is virtual methods and dynamic binding. In this content, have 2 parts. The first one is virtual method. Sysad virtual method is a method that can be redefined in base classes. A virtual method in the class is a method that can be redefined by overload or override by the derived class. If you want a method to be virtual, as the virtual keyword to the function name declaration. In Sysad, a virtual method has an implementation in a base class as well as derive the class. It's used when a method's basic functionalities is the same, but sometimes more functionality is needed in the derived class. When a method is declared as a virtual method in a base class, then that method can be defined in a base class, and it is optional for the derived class to override that method. The overriding methods also provide more than one form for a method. Hence, it is also an example for polymorphism. When a method is declared as a virtual method in a base class and that method has the same definition in derived class, then there is no need to override it in the derived class. But when a virtual method has a different definition in the base class and the derived class, then there is need to override it in the derived class. When a virtual method is involved, the runtime type of the object is checked for an overriding member. The overriding member is the most derived class is called, which may be the original member if no derived class had overriding the member. Virtual methods in Sysad. 1. By default, methods are non-virtual. We can override a non-virtual method. 2. We can use the virtual modifier with the status, abstract, private, or override modifiers. Difference between virtual and non-virtual methods. We have 2 classes. One is a vehicle class and another is a car class. The vehicle class is the base class that has 2 methods. One is a virtual method base and another is a non-virtual method average. So the base class virtual method speak is override in the subclass. We have one more class program, the execution class, that has an entry point where we create an instance of subclass card, and that instance is assigned to the base class is vehicle type. When we call virtual and non-virtual methods by per class instance, then according to the runtime, The instant virtual method implementation is involved. In other words, both class instant involve the subject class override methods and the non-virtual method involved is determined based on the instance of the class. You can see the code on the screen to understand better. And the next one, dynamic binding, a technique called overloading. To overload the tree, declare the methods by adding the override keyword. If you want to execute the code of a function that is defined by this base class, you need to call it through the base notation. The first one, create a class product, varies assigned with value 0. Create a virtual method is product info. Assign the product info method is declared as a virtual method in the class that inherit it. It can be redefined a technique called overloading. To distinguish virtual methods, the word virtual is often added. Example, public virtual void product info. In the derived class, it is possible to redefine the virtual methods of the base class. This is overloading. To overload, just redeclare the methods by adding to the override keyword. The next one, create class iPhone inheritance class product. To perform for iPhone, building a method to initialize iPhone, set the price to 500. The iPhone class has redefined the product info methods, so the call to product info are completely different from its original definition. However, if you want to execute the code of a function that is defined by the base class, you need to call it through the base notation. The syntax of virtual methods. The first one is virtual word. The next one, data type. The next one, name methods. And the last one, parameter. The constructor cannot be virtual, but the constructor can be virtual. Using virtual methods is slower. Regular methods become when the new implementation is specific. So, why do we need virtual functions anyway? For most of us, something makes sense only when we know the reason behind it. It just doesn't make sense. Why would I want to use such a product info class when I can simply create a separate iPhone class, even if the base class were a self and derived class were rectangle and triangle. I can override the base class function without using virtual. Then why virtual methods? And who needs virtual methods? If you are a beginner programmer, you don't really need to worry much about virtual functions. It's likely you would be using most of it anyway. But if you are an intermediate or advanced programmer who has come to realize that creating software takes just 10% of your time and 90% of time will be span, the altering the code and maintaining the software through its life cycle, then you definitely needs to understand why virtual functions can help you write the decoupled, flexible, encapsulated, maintainable code. And we will go to an example. Let's say you are writing a very complex battlefield software which is being used on the defense troops. The software capable of monitoring device on the truck, communicating with the enemy command control center situated far away, and is also capable of doing a lot of other things. One other function of battlefield software is to use a command to a gun mounted on the troops to fire ammunition. Normally, you would create a gun one boy fire function in a battlefield software, which directly involve the gun fire function. But what will you do when this gun is removed and a missile launcher or a gun from some other company is fitted? Though weapons have different functions for shooting, and two company refuse to change their function name to fire. So what the problem? You tell me, hey, no problem, I don't mind changing the function, it's just one function after all. But you don't see the full picture here. Gun one boy fire might not the only command that battlefield software use. There might be many other places in the software where the gun one object is, and we will go to an example. Let's say you are writing a very complex battlefield software which is being used on the defense troops. The software capable of monitoring device on the truck, communicating with the enemy command control center situated far away, and is also capable of doing a lot of other things. One other function of battlefield software is to use a command to a gun mounted on the troops to fire ammunition. Normally, you would create a gun one boy fire function in a battlefield software, which directly involve the gun fire function. But what will you do when this gun is removed and a missile launcher or a gun from some other company is fitted? Though weapons have different functions for shooting, and two company refuse to change their function name to fire. So what the problem? You tell me, hey, no problem, I don't mind changing the function, it's just one function after all. But you don't see the full picture here. Gun one boy fire might not the only command that battlefield software use. There might be many other places in the software where the gun one object is instant is being evolved. There might be a gun one boy calibrate gun command, gun one point position gun command, gun one point reload command, and so many more. Are you going to train all of them in real world software? the course becomes so complex that it wastes a huge amount of time making corrections like the once corrections make they have to be tested too because you might have unknowingly make some change and introduce a bug. You would have to go into Bellify software and change Gun1.5 to Gun2.6 or Masalature.large. Then complete everything again and test it on over again. The first part of the solution is to create a separate software module named weapon controller which will poorly be in a trench of interfacing with the weapon mounted on the truck. Now, Battlefield software can be programmed to contain an instance of a weapon controller and a source target. Battlefield software just have to call weapon controller upon a source target. The weapon controller class will decide whether to configure or lower or source. So even if a gun from a new company is brought in, the trench only has to be matched to the small weapon controller program. The compilation will be faster and the testing can also be done quickly because you are only modifying a weapon controller, so you are sure there won't be any bug introduced into the big Battlefield software program. Implementation now come the interesting part. How do you purpose to implement a weapon controller? One way will good success is a simple implementation just to keep it short. So
now I will attract class. The first attract class or attract by class cannot be used to instance address or attract by class to add to general to preview object. They specify only what is common among derived class. Class can be used to instance object as constraint class. Constraint class provide the specific that makes it reasonable to instance object. An object class normally contain one or more object methods which have keyword abstract in their declaration. Abstract that contain abstract methods must be declared as an abstract class even if it contains real or non-abstract methods. Abstract methods do not provide implementation, constructor and static methods cannot be declared abstract. And now summary abstract class is also a case showing showing the polymorphism of OOP programming. When declaring a class with the abstract keyword, it's an abstract class. It is an abstract class. As an abstract class, it is not used to instance object directly, but it is only a base class that inherits from another class, and in an object class is some special feature such as it is declared with the abstract keyword. It can declare 0, 1 or more inside the method object. And the last, you cannot instance an object directly from a class object. And to be better understand polymorphism require the following true type of code. In the abstract class, it is also possible to declare an abstract method with the abstract keyword. This method has the body or only name parameter. It requires the inheriting class to be overloading or overriding. Define as about product is an abstract class. It has an abstract function product info. This function requires the direct class to override it. Since product is an abstract class, it should never be used to treat object. The product is only for inheritance. Abstract function must override. Now I will talk this code. Now I will talk some abstract class. A class has at least one object method must be declared as abstract. This is an abstract method. It has no body. Accept modify of this is method public. Um, accept modify the accept level. And accept modify the protected. This is an abstract class. This is delay abstract even though it has no abstract method. And now I will talk abstract property. Abstract property declaration have from public abstract return type. My property An attract property may omit in implementations for the get accessor, the set accessor of above. This is example for attract class. The class has at least one method object must be message e object attract, and um, this is an attract method. This is an attract method. It has no body. This method returns the name of the job, and then this is an attract method. Method has no body, and the last, this is a regular method non-attract. Attract. And now we will talk about, and now we will continue with Duy.
Right. Hello everyone. Hello lecturer. My name is Phạm Nguyễn Hoàng Duy, one of the members of Group 7, whose presentation is happening at the moment as we speak. As my teammates have said earlier, this presentation have 5 main sections to cover. And from the previous teammates, you get to know that the visual method and dynamic binding is, and what is abstract classes. So in this section 3 of the presentation, I'll cover up the polymorphism part, one of the important aspects of C# programming. So first off, we need to know what polymorphism is. So polymorphism is a Greek word. It means one name, many forms. In other words, you can call it as one object that has many forms, or one object has one name with multiple functionalities. There are two main parts of this word, poly and morph. Poly means many, and morph means forms. So basically, that's what the word means in language for any linguist. Polymorphism, it provides the ability for a class to have multiple implementation with the same name. It's one of the core principles of object-oriented programming after encapsulation and inheritance, which you have known from previous weeks. In this section, you will learn what polymorphism is, how it works, and how to implement polymorphism in C#. As I said earlier, in C#, polymorphism, it means providing an ability to take more than one form, and it's one of the main pillar concept of OOP after escalation inheritance. It also provides an ability for the classes to implement different methods called through the same name. It provides the ability to invoke or derive the class's methods through base class reference during runtime based on our requirements. Which means you get to reuse the thing in the class, or avoid you get to reuse it in a new one. or we call it a second type through a different name but similar principles. As I said earlier, it has that's the basic concept of polymorphism. Uh, sorry for if the image is a bit blurry, but um, here we go. So polymorphism, it has two main types: static or compiled time, or dynamic or runtime. Dynamic or runtime, it has a virtual or overriding method, while static or uncompiled time, it is separated into two main methods. That is methods overloading and operator overloading. With, so from now we will be covering the leftmost part of the map, which is static or compiled time polymorphism. Static or compiled time polymorphism, it means defining multiple methods with the same name but with different parameters. Using compiled time polymorphism, we can perform different tasks with the same method name by passing different parameters. In C#, the compiled type polymorphism can be achieved by using method overloading. You can call it as early binding or static binding or method overloading if you want, or operator overloading. So in this example, as you can see in here, which is a code that implements method overloading. As you can see here, in the subpublic int at int a int b return a plus b, and focus on this part here. We have public int at int a int b int c return a plus b plus c, which means we have the same parameters here. Oh, sorry, it means we have different parameters here, abc, where here is only ab, but we have the same name that add in the class data. Computer class programs, we can simply get int add 1 with 2 values, add 2 with 2 values, 3 values. And this my map here will show you. It shows that int add 1 here, it will connect to the int add int a int b, and the 45, 34, 67 over up here, it will connect to this. Public int add int a b c return a plus b plus c up here. Next, we cover up the operator overloading. As the name suggests, operator overloading, it mainly involves with operators, which in this example is the, you can see over here, it's quite long, but it won't take you much time. It has the plus operator. So starting from this, we add the that we calculating the volume of the box here with length, breadth, and height with the some simple algorithm that you have learned from middle school and high school. So for the operator, the imposing the overloading, as you can see the public static box operator, we have the operator plus, and we add in two different parameters. And then we create two new from this we create two new box length, and we return the same parameter box. Let's test this. The code continues here to here to here to here. So by using the operator overloading the addition overloading, we can add we can call it three different column boxes. 1, 2, 1, 2, 3. When you use the overloading or our overloading, it depends on the situation, what you want to use best in the situation that you're implementing. Now we cover up the remaining part of my map which I've shown you earlier, which is dynamics or runtime polymorphism. Dynamic or runtime polymorphism, it means overriding a base class method in the derived class by creating a similar function. This can be achieved by using override and visual keywords and the inheritance principle. Using runtime polymorphism, we can override a base class method in the derived class by creating a method with the same name and parameters to perform a different task. So it's different from before that we have the same name, same parameters, while the previous one is same name but with different parameters. In C#, the runtime polymorphism can be achieved by using method overriding. You can call it labeling or dynamic binding. From this example over here, we have this the principal public class drawing, public dimensional double area, region 0, blah blah blah. But here's a part got interesting. As you can see, it says the same name. It shares the same name. It shares the same parameters. And to use this, you have to do a circle, start drawing to perform runtime polymorphism. So here is circle, we have to take here square. Square also we got the same report area and the same name. We consider the code here, and as you can see, the override double area, which I'm not going to show. Same thing happening with rectangle drawing, name, parameters. And since the rectangle, it height times width. And from there we will go to the class program, the main string. We can simply do this as usual, and we run the complete program. So the runtime program is quite easier to grasp, but you can see the code is quite long. But as I said earlier, how to use whichever one of these things, it will depend on the situation that you want to use. So from this is a graph table, which is this is the main. It takes a three main class, and they have the same probably over same area, the same parameters, and the same name from the original source. That's the end of my presentation on polymorphism. I'll leave it to my next teammates from now on.
The next one is method overriding. In OOP, overriding and overloading are two techniques that help create polymorphism. One of the strengths of object-oriented programming. Override is used when you want to change the behavior of the methods in the parent class or pay class, in the child class, or derived class. Basically, suppose there is a method in the superclass that when run it will output the result A, but according to some logic, you want to run this method in the subclass to output the result B. When you use the override keyword and characteristics of override. The first one, override only occur between classes with inheritance relationship. The override methods in the parent class and the override method in the child class must be identical in all three parts: return database, method name, and parameter list. Only methods with access modifier that are public or protected can be override, and it cannot change the access modifier of the method to the method is override. The override methods and override and offload methods must have the same access modifier. The override keyword is used to implement an iterative methods, property, indeter, or event when it's used with the abstract or virtual keyword. The next one, cannot override static methods or non-virtual methods. The next one, cannot use modifier like new, static, virtual for override methods. And the last one, cannot override constructor. An override method provides a new implementation of the method inherited from a base class. The method that is override by an override declaration is known as the override base method. An override method must have the same signature as the override base method, beginning with Sysad 9.0. Override methods support covariant return type. In particular, the return type of an override method can derive from the return type of corresponding base method. In Sysad 8.0 and earlier, the return type of an override method and the override base method must be the same. You cannot override a non-virtual or static method. The override base method must be virtual, abstract, or override. An override declaration cannot change the asset of the virtual methods per the override methods, and the virtual methods must have the same asset level modifier. You cannot use the new static or virtual modifier to modify an override method. An overriding property declaration must specify exactly the same access modifier type and name as the inheritance property, beginning with Sysad 9.0. Read-only overriding property support covariant return type. The overriding property must be virtual, abstract, or override. For example, you have an animal class animal. Create method is big is virtual methods. Now you have specifics such as dog that inherit from the animal class with the specific cry go go. This time we will override the speak methods of the parent class. And you have animal pet cat that's also inherit from the animal class but doesn't override the speak method of the superclass. Now if you instant to object dogs and a cat bring our cry for each result is go go. Thus you can see that the dog override the animal cry action. It will be its cry. If the cat do nothing, its cry will be the general cry of its parent class. And now we presentation talk about interface.
Hello everyone, I'm Yi, and now I'm going to talk about interface. So, what is interface? Interface is a blueprint for a class. It's an abstract class because all the methods which are declared inside the interface are abstract methods. However, it cannot have method body and cannot be instantiated. The usage of interface is that it can contain declaration of method, properties, indexes, and events. It's used to achieve multiple inheritance, which can be achieved by class, and it's used to achieve fully abstraction because it cannot have a method body. When you first create an interface, you must know that all members of the interface are public by default. So if you use an access modifier in an interface, the C# compiler will give a compile time error, such as this modifier public, private, protected is not valid for this item. Here and here. An interface can only contain declaration but not implementation. So the following will give a compile time error. You can have this, but you cannot have this. This will give an error. These are some samples of interface. So first we got the simple interface. You might notice that above all have an I in the first letter. That's the first letter right here. So it's usually used as the name of the interface to show you easily that this is an interface. Then you declare some method. Next, you have an interface and a class that inherit it. Here I have my interface. And then the class my class that inherit my interface, which then implement the method 1 and 2. Also, there will be an identifier. You don't have identifier on the interface, but you must have it over the class. The third example will be this one. We have two interfaces, iProduct and iOrder, which the class product will inherit both of them. This is a simple example to show you that class can inherit multiple of interface. Here is the pros and cons of using the interface. The interface makes grouping and sorting of code an easier task because of its reusability and its definition of the separate component of any class. The interface also reduces the dependency of one class on another. Implementation of also it has the implementation of multiple inheritance. One class can inherit many interfaces. The implementation also, but there's a cons when using interface. The implementation of multiple interfaces at once can create errors such as conflicting members. So you have to bear in mind that an interface does not have too much method, because this makes the implementation of all method by class too complicated. An interface can only be used to define the common element of a set of class. It cannot be modified to include details specific to a few. The detail would then be implemented by all class in question. As I said before, interface is a blueprint of a class. It doesn't have all the detail of that class. And also it has slow performance due to it has to load the method from the corresponding class instead of run directly. Here is a table that shows the differences between interface and abstract class. So the interface only contains a declaration part, while the abstract class contains both of the declaration and definition. The interface can have multiple inheritance, while you cannot have that with abstract class. An abstract class contains constructor and static members, while interface doesn't. Abstract class can contain different types of access modifier like public, private, protected, etc. When interface just have public access modifier. abstract class performance is fast. However, interface performance is slow because it requires time to search for actual method in the corresponding class. Abstract class is used to implement the core identity of the class, which is the details, while interface is used to implement the peripheral abilities of the class, which means the structure, the blueprint. A class can only use one abstract class, but it can use multiple interfaces. If many implementations are of the same kind and use common behavior, then it is superior to use abstract class. But if they have the same method, just only the same method, then it is better to use interface. Abstract class can contain method, field, constant, etc., while interface can only contain method. An abstract class can be fully or partially or even not implemented, while you have to fully implement an interface. And that will be the end of our presentation. If you have any question about any part, please comment. Thank you.